All right, today we are making our way into the last topic from chapter 9, which is trigonometry. Now, this is something that most people in the previous years that I've taught this have found to be really easy, so I'm confident that you will as well. So trigonometry applies again to right triangles, as everything we've done in this chapter has. And what we can use trigonometry for is to find lengths of triangles where we don't have enough information to use Pythagorean theorem or special right triangles. So the first thing that we need to address is identifying parts of our right triangles as they relate to our reference point, or what we call the reference angle. So in this right triangle, if I am using angle B as my reference angle, there are three sides to this triangle: opposite, adjacent, and hypotenuse. The opposite side is going to be the one across from your reference angle, so here that would be side AC. Your adjacent side is the one that touches your reference angle, so that would be BC. And then your hypotenuse is always across from your right angle. That's something you should already be familiar with. So then if I look at that same triangle, but I use A as my reference angle instead, the opposite leg from A is BC. The adjacent leg is AC, and my hypotenuse is BA. So notice when you change your reference angle, and the reference angle will always be one of your acute angles, the hypotenuse does not change, but your opposite and adjacent legs switch. So once we are able to identify our opposite, adjacent, and hypotenuse sides, how are they helpful? Well, we use them in what we call trig ratios, and those ratios are sine, cosine, and tangent, which we'll get into a little bit more about what each of those means. But first, what are the trig ratios? Again, a ratio means fraction. So the sine of an angle is the opposite divided by the hypotenuse. The cosine of an angle is the adjacent side divided by the hypotenuse. And the tangent of an angle is the opposite side divided by your adjacent side. And a way that has been around, a little mnemonic device to memorize these ratios, it's been around for a long time, is SOHCAHTOA. So sine, opposite over hypotenuse; cosine, adjacent over hypotenuse; and tangent, opposite over adjacent. SOHCAHTOA. If you can remember that, then you can remember your trig ratios. So what are these ratios? Fractions. So now in this right triangle, I have my three sides. So we're going to practice using those sides to write our sine, cosine, and tangent. So the sine of M is my reference angle. So if I want the sine, remember sine, that's going to be opposite over hypotenuse. So in this particular triangle, my opposite side is 7 long, and my hypotenuse is 25. So that ratio or fraction is just going to be 7 over 25. Then to get that as a decimal, all I'm going to do in my calculator is divide 7 and 25. So the decimal value would be 0.28. Okay, cosine, still same reference angle. That's going to be adjacent divided by hypotenuse. My adjacent side in this triangle is 24 long, and the hypotenuse is 25. So there's my fraction. And if I want that as a decimal, all I'm going to do is divide in my calculator, and I get 0.96. Okay, then lastly, tangent. That's opposite divided by adjacent. So my opposite side is 7, my adjacent side is 24. So I've got 7 over 24, or rounding to 4 decimal places, 0.2917. So again, don't panic. Sine, cosine, and tangent are just numbers. So we're going to practice now using these in the calculator. And again, we need to make sure we're in degree mode. So if you're using one of these calculators that we have in class, the way you make sure you're in degree mode is you hit this mode button here. And down at the bottom where there is radian and degree, you need to make sure degree is what is selected, because that is how we're measuring our angles. So I can now find the tangent of 50. So my trig buttons are here, sine, cosine, and tangent. So if I want the tangent of 50, I'm just going to press tan 50, and there I have it. Then I can do the same thing for cosine and for sine. So there are those three values. So again, cosine, sine, and tangent are just numbers. So let's look at how we use them to find missing sides. We'll do that on the back side now. So if you know an angle and one of the sides, you can find other sides in your right triangles. So what we're going to do here on 3 is I'm going to look at, here is my reference angle 53. That's the one I'm given. I'm looking for the opposite side and I'm given the adjacent side. So which of my 3 ratios uses opposite and adjacent? Well, that's tangent. So I know that the tangent of my angle 53 is going to be equal to the opposite divided by the adjacent. So this is the equation that I'm going to use to solve for x. So to get x by itself, I need to multiply both sides by 24. So I'm going to have 24 times the tangent of 53 degrees. Now remember, tan of 53 is just a number. So this is where we get our calculator. And we're going to do 24 times the tangent of 53. And there is my x value, 31.8491. We'll just keep going with the 4 decimal places. Okay, let's move on to number 4. Here's my reference angle 31. I'm given the opposite side and I want to find the adjacent. Again, I'm working with opposite and adjacent, so that's going to be tangent. So the tangent of my reference angle 31 is going to be equal to opposite 7 divided by adjacent. So this time I've got x in the denominator. So the first thing I need to do is get it out of my denominator by multiplying both sides. So I've got x times the tangent of 31 equals 7. And then the last thing I need to do to get x alone is divide both sides by the tangent of 31. So x is going to be 7 divided by tan 31. Once I'm at this point, this is where I get my calculator. And I'm going to do 7 divided by the tangent of 31 degrees. And my side in this triangle is 11.64. That's going to round up, 6450. Because I've got those double 9s. Come on, white out. 650. Okay, moving on to 5. This is my reference angle 51. I'm looking for my opposite side and I'm given the hypotenuse. The ratio that uses opposite and hypotenuse is sine. So the sine of 51 degrees is going to be equal to opposite x over hypotenuse 63. So to solve this one for x, I'm going to multiply both sides by 63. So 63 times sine of 51 is going to be equal to my missing side. And that's what I'm going to type in my calculator, 63 times the sine of 51. And that missing side here is 48.9602. Okay, the last one for this row, and I know I'm kind of low on space here. On 6, my reference angle that I'm given here is 63. I'm looking for the hypotenuse and I'm given the opposite side. So again, opposite and hypotenuse tell me to use sine. So the sine of 63 is going to be equal to opposite 43 divided by x. Now remember, when x is in the denominator, the first thing that you're going to have to do is get it out of your denominator. So x times the sine of 63 equals 43, and then divide by sine. So what's going to go in my calculator is 43 divided by the sine of 63 degrees. Okay, and I get, I don't want that button, 48.2600. Okay, moving on to that last row. On 7, my reference angle is 28. I'm looking for the adjacent and I'm given the hypotenuse. Adjacent and hypotenuse tell me to use cosine. So the cosine of 28 is going to be my adjacent divided by my hypotenuse. So I'm going to multiply both sides by 44. And 44 times the cosine of 28 degrees is what's going to go in my calculator to give me my x. And I get 38.8497. Now I can move on to number 8. My reference angle is 41. I'm given the adjacent and I'm looking for the hypotenuse. Again, if I'm working with adjacent and hypotenuse, that tells me cosine is what I'm going to use here. So adjacent over hypotenuse for that one will be 48 over x. So first I got to get x out of the denominator. And then I can divide by cosine of 41. So 48 divided by the cosine of 41 is what's going to go in my calculator. 41. And I get 63.6006. Okay, just 2 left. On 9, this is my reference angle. I'm given the opposite and I want the adjacent. Opposite and adjacent tell me to use tangent. So the tangent of 27 is going to give me 101 over x. So I got to get x out of the denominator. So x times the tangent of 27 equals 101. Then I can divide both sides by the tangent of 27. So what's going to go in my calculator is 101 divided by tangent of 27 degrees. And I find that my missing side is 198.2237. And then my final one, here's my reference angle 19. I want to find x and y. Well, let's find x first. I'm given the hypotenuse, and if I want to find x, that's my opposite side, so that's going to be using sine. So the sine of 19 degrees is going to be equal to x over 22. So I'm going to be multiplying 22 by the sine of 19 to get x, and I get 7.1625. Then to find y, I've got the same reference angle, but this is my adjacent side and I know the hypotenuse, so I'm going to use the cosine to find y. Adjacent over hypotenuse. So 22 times the cosine of 19 will give me my y value. And I get 20.8014. And that is how we use trig ratios to find missing sides in our right triangles. Again, remember those ratios, sine, cosine, and tangent, are just numbers, and you're going to want to memorize SOHCAHTOA, which is a lot easier than you think.